All right, let's talk about one of the biggest, most fundamental ideas in the entire universe, time itself. I mean, what even is it? We're going to dive into that today using Chapter 17 of String Theory for Dummies as our map. We'll explore why you can remember what you had for breakfast, but not what you'll have tomorrow, how you could actually slow down your own personal clock, and what string theory has to say about the very nature of time. You know, this quote from St. Augustine, written more than 1600 years ago, just hits the nail on the head, doesn't it? It perfectly captures this weird paradox about time. We live it, we feel it every single second, but the moment you try to actually pin it down and explain it, poof, it just slips right through your fingers. It's somehow both totally obvious and this deep, profound mystery. So let's start with what we think we know. Okay, first up, let's tackle our everyday experience with time. It feels like a one-way street, right? It's always moving forward, never in reverse. In physics, this is called the arrow of time.
But here's the really weird part. This one-way direction is actually kind of strange in physics. Most of the other fundamental laws, like gravity, for example, they don't care about the direction of time. A planet orbiting a star would follow the exact same rules if you ran the video backward. So why is time different? Why can't we unbreak a glass?
Well, the answer seems to lie in this one concept, entropy. Entropy is basically a measure of disorder or chaos. And here's the key. It is the one physical law that has a direction baked right into it. The second law of thermodynamics says that in any closed system, like say our universe, things will always naturally move from a state of order to a state of disorder. This relentless march toward chaos is what gives time its forward arrow.
Think about it like this. It's super easy to go from a whole, perfectly ordered egg to a scrambled, totally disordered mess. That's entropy increasing. But if you ever seen a pile of scrambled eggs just spontaneously reassemble themselves back into a perfect whole egg sitting in its shell? Of course not. The odds are just so astronomically against it, it basically never happens. That is the arrow of time in your kitchen.
Okay, so time only moves forward. But what if it's not as rigid as it feels? What if we could actually bend it? This is where a certain Albert Einstein walked onto the stage and completely changed the game.
So, Einstein's theory of special relativity just blew everyone's minds. It showed us that time isn't this absolute, universal clock ticking away for everyone at the same rate. Nope, it's relative. And one of its craziest consequences is something called time dilation. Put simply, the faster you zip through space, the slower you move through time, at least compared to someone who's standing still.
To really get this, just imagine you have two twin astronauts. One stays home on Earth, and the other hops on a spaceship that travels close to the speed of light. When that traveling twin finally comes back to Earth, they might have only aged a few hours, while their twin back home could be years, even decades older. They have literally, physically traveled into the future. It's real.
And get this, it's not just about speed. Einstein's general theory of relativity showed that gravity itself can warp the very fabric of spacetime. So the stronger the gravity, the more it slows down time. Now, this effect is super tiny here on Earth, but if you get near something massive, like a black hole, it becomes extreme. You've probably seen this in the movie Interstellar, that amazing plot point where 1 hour on the water planet was equal to 7 years back on their ship. That wasn't just science fiction, it was based on real physics.
So, we know we can bend and stretch time, but could we do even more? Could we, punch a hole right through it? This is where we get into the classic sci-fi dream, wormholes. I mean, this has got to be one of the most tantalizing questions in all of theoretical physics. The math of general relativity actually allows for these kinds of cosmic shortcuts to exist, but could they really be our ticket to time travel? So, a wormhole, which is also called an Einstein-Rosen bridge, is basically a theoretical tunnel that connects two totally different points in space-time. So you could step into one end here and instantly pop out somewhere else across the universe, or maybe, just maybe, somewhere else in time.
So, time machine, here we come, right? We're going to go visit the dinosaurs. Well, not so fast. While wormholes are mathematically possible, turning one into a working, practical time machine is a whole different level of difficult. In theory, here's the recipe. First, you create a stable wormhole. Then, you leave one end of it right here on Earth. You put the other end on a super fast spaceship and zoom it away close to the speed of light. Because of time dilation, time will pass way slower for the spaceship's end. So after a few years, you could just step from the Earth end into the spaceship end and walk out into Earth's past. Simple, right? Yeah, well, here's the reality check. For starters, these things would be incredibly unstable. They probably collapse the instant they formed. Second, the gravity inside would be so intense it would literally shred anything trying to pass through. And finally, the big one. To keep a wormhole propped open, you'd need huge amounts of something called exotic matter, which is this theoretical stuff with negative energy that we have never actually found and aren't even sure can exist. So, yeah, a few minor problems.
Now for the grand finale. Let's venture into the really, really wild territory of string theory. I mean, the bending time and wormholes weren't enough to bake your noodle. Some theories suggest there might be way more to time than we could ever imagine.
This is an idea called two-time physics. And yes, it is just as mind-bending as it sounds. It comes out of M-theory, which is a cutting-edge version of string theory. And it suggests that our universe might not just have one dimension of time, but two. We only see and experience one, that familiar, forward-moving arrow. But another one could be hidden from us, curled up so small that it's totally imperceptible, kind of like the extra spatial dimensions that string theory is so famous for.
And that just leaves us with this incredible thought to chew on. We've gone from a simple egg scrambling in a pan all the way to the mind-blowing possibility of a whole other dimension of time. Our understanding of what time is just keeps evolving, and it really makes you wonder, if something as basic as time can have all these hidden depths, what other fundamental truths about our reality are just sitting there, hiding in plain sight, waiting for us to discover them? Thanks for joining me on this one.